Welcome back to the channel and to this week's video. So this week I'm going to be focusing in on the Speedo and the Tacho. I'm going to teach you how to test and calibrate them. Now this is specifically for my 928, but it should work for any 911, 944, 924 and probably many non-Porsches as well. What we're going to be doing then, I've taken both of them out of the cluster itself and we're going to be using a little Arduino microcomputer. Now they're available online for about probably 10 bucks, £6, something like that, and a few other components. So in this video I'll cover all of the pieces you're going to need, how to connect them up, what software you need to install on your computer, laptop or computer, and I'll actually give you the program which I'll copy into the description to actually do the work itself, to do the calibration. So hopefully you enjoyed this video. If you're new to the channel, this is one of many videos behind now, 86 or something like that, that cover the restoration of my Porsche 928. And as I say every time, I'm no mechanic, I don't really know what I'm doing. I'm just a guy having a go. So please leave comments, click that like button, that's really valuable to me. And please subscribe, you know, who knows, you might enjoy yourself. Anyway, let's jump in now. I'll show you how I do it and what parts you need and we'll get it done. Now Arduinos are fantastic because they are so cheap and they provide a direct link between code, so software, logic, and hardware with those input and output pins. You can pretty much plug anything into it that provides a signal, so you can have, I don't know, whether it be like a PIR sensor, one of these security lights, or the Speedo or the switches in a car, pretty much anything. And with logic on the microprocessor, you can control the output. So how we're using it is we're not using any inputs, we're just using the output pins. And I'm using it to produce a square wave, which is the type of signal the 928's ignition system sends out. So this is the Arduino, the brain behind all of the tests we're going to be doing. This is specifically an Arduino Uno R3, which you can buy very, very cheaply online. I'll provide a link in the description. It has one, if I can point to there, it's a 32-bit ARM processor linked up with a number of input and outputs. So I can't point actually. These are all the inputs and the outputs are over here. You can power it up. Mine's being powered by a USB cable going into my laptop, but you can give it an external power supply so you can move away from controlling it via a laptop. And you program it using C or C++ in an editor that you can download free of charge online. Again, I'll provide links in the description. So what you're going to need to do this project? Well, you're going to need a cluster, of course. Now I've taken my Speedo and Tacho out and I've got them here on the bench. And I recommend doing that because what we want to do is actually test and calibrate these items and not be testing the circuit board that's on the back of the cluster. That's another project, we'll come to that somewhere down the line, but for now we're only interested in the Tacho and the Speedo and calibration of those, testing and calibration. You're going to need an Arduino, and as I say, I'll provide a link below, but they're very cheap, but just grab one of those. You're going to need a number of wires. I'll pick some out and put a link below. I've got I bought like a little pack of connectors that you can press together, which are really handy. You'll also need a breadboard. Now somewhere I have one here. Now this is a really nice way of doing it, if you can see that. A breadboard, you can just press the wires in. These are the wires I bought. Super handy for knocking this stuff up quickly. I've gone one step further and soldered mine back all together so it stays permanently, but this is great for prototyping stuff and doing things quickly. You're also going to need a car battery. Now I've got a spare car battery that I've picked up somewhere along the line. Definitely have a battery, and when I show you in a little while the battery will be back on the desk here. You're also going to need one transistor. Again, I'll link it below. That's going to be pressed in, oops, it's actually here in the breadboard now. You can't quite see it, perhaps it's just there that I'm tapping. And you're going to need the Arduino IDE. That's a piece of software. Again, I'll put a link below. Download it, install it on your laptop, on your computer, and I will give you the bit of software that you add, cut and paste into that to run. Now in terms of circuitry, so this is my entire setup, sans the battery which will be there in a little while. Arduino, obviously the two Speedo and Tachos, loads of wires and the circuit board. This is the bit we're interested in now. So I'll give you the circuit diagram. It's really straightforward. There's no major problems with it. The only minor complication is the transistor. Now we need the transistor to be able to send a ground signal, a grounded square wave to the Tacho. And that's the only complicated bit here. The rest of it is just connecting wires to wires. And it avoids having this sort of thing everywhere. Obviously, I have to put this somewhere because this necessarily needs to connect over to the Speedo. Well, that's the Tacho, that one. This one here goes to 12 volts. I'm just working my way through labeling them all now. When I'm complete with this project, I'm going to pop that away. That'll be my calibration testing device for later use. And as I mentioned earlier, you can use a breadboard. Now these are great because you can just press things in. You can just take a wire and push it in the little hole and it makes a connection. So a breadboard is set up such that all of these connectors across the top are connected on the horizontal and across the bottom horizontally, and then any in the middle are connected vertically. So to connect up to that transistor, I can just pop a wire in like that. Oops, if I can do it. That wire now connects to the left-hand leg of that transistor. It's very clever how they work, like that. Okay, so let's take a look at the circuit diagram. It's not really a circuit diagram, it's more of a sort of flow diagram really. The important parts then, so we have the laptop and the battery, both down here, and the Arduino, and then the Speedo and the Tacho. Now I've shown the wiring, so the 12 volts come out of the battery and go both to the input the 12 volt inputs for the Speedo and the Tacho. Same with the ground, so the 0 volts is the ground. That comes out and goes to both. The interesting one is the blue connector. That's the signal. So the Tacho is relatively straightforward. That connects straight up to pin 13 on the Arduino. Say the Arduino is going to be pumping out a square wave. So that square wave goes directly into the Tacho, and it's that will make the needle go up and down. The Speedo is slightly different. So for the Speedo's signal, it needs to be grounded. And the way to do that is to connect the ground into a transistor, which then flows through to the Speedo. Now the transistor is triggered by an output from the Arduino on pin 12, which is pumping out a square wave. So the square wave is basically, it goes it's 0, then it sort of pulses up to 5 volts and back down again, and that's what will open the gate here and allow the grounding of the signal pin here, like that. It's a pretty straightforward circuit diagram. I'll leave it on the screen for a little while just so you can get it. And that's all we're going to be wiring up. Literally, you just wire up what you see here. Right, then we come to the car battery. Now, I can't emphasize, be so careful with the car battery. Although it's only 12 volts, it's got a lot of ampage, a lot of power in there. If you short across here, you know, it will do some damage. What I tend to use is this. So, okay, it's cobbled together, but it's a fuse. So the red wire comes off, goes through this fuse, and then off to my Arduino circuit board. It just means that if it gets shorted, it will blow the fuse here, and it saves any of the equipment. Please do something similar. We're dealing with a lot of volts, and if you look at how I have the wiring here, you know, it is a little bit loose and happy-go-lucky. I've done this a lot, so I'm relatively confident with this, and I'm very good at keeping the ground and the 12 volts apart, the positive and the negative apart. Be so careful with this, I can't say it enough. Alright, next we come to the software. If you just search for Arduino in Google or something, and it's pretty much the top one, I believe. Although I think that's the store, but I think it would take us all roads lead to Rome. I'm going to click on the Arduino, sort of the home page up the top there. And then what we're looking for is software. So I'm clicking software and then downloads. So it's a free download, Windows there. Click it, download it, install it. It is free. You can donate if you'd like to, or you just click the just download button. That will start it downloading. It's not a big program, so it will download pretty quick. I think it says there 160 megabytes. Okay, it's not that small, but it'll be down in about 30 seconds. Download that, install it. Once you have it installed, it will look like this. So if we just start a new one, right. So when you start it, it will look exactly like that. It's pretty, not a great deal there, just the beginning stuff. What I'm going to suggest you do is you delete that, and then I will copy and paste this code, which is the actual program we're going to use. I'll copy and paste that into the description for this video. So what we're going to do is copy and paste it in like that. So that's in there now. And I'll walk you through the program in a second. What we do to compile is just click this tick. So if you just click the tick once you've got it pasted in there, and you should see no red text here at all. So there's nothing there, it's just white text, which means that it's all worked okay. If there's red text, you've hit a problem, and it's more than likely you've not cut and pasted it all in here correctly. So just double check, and once you get so that when you click the tick, it compiles, which means it's compiling done, no errors, then we can progress. So now's the hard part. We need to work through the software, and I'll try and explain how it works. So we need the Arduino to output a square wave. And by a square wave, I mean a voltage that goes from 0 volts up to 5 volts, stays at 5 volts for a period of time, drops down to 0 volts, stays at 0 volts for a period of time, back up to 5 volts, and repeats. So we end up with this kind of like a square wave. The secret is the gap of how long it stays at 0 volts and how long it stays at 5 volts. How long at 0, how long at 5. And that's what the ignition system of the car does to tell the Speedo or the Tacho what speed, what RPM it's going. So the Arduino, we need to count incrementally. So let's say we're working in seconds. I need the Arduino to count sort of 1, 2, 3, 4, then go up to a high voltage, 1, 2, 3, 4, down to a low voltage, 1, 2, 3, 4, back up to a high voltage. Now we're not talking in seconds, we're talking in microseconds here. So, or they're actually milliseconds, but I'm working in microseconds. So what we're going to do is write a small program that runs around the loop very rapidly, and it's going to be counting and adding up. And when we, so it's going to be adding, and when it comes to a threshold, it's then going to change the output to high, to 5 volts. Then it's going to be adding up again, and when it gets to a certain threshold, it'll drop down to 0 volts, and keep doing that. And the reason we do that is because I want to drive the Tacho and the Speedo at the same time. I want them both testing and calibrating at the same time. And there's a little complication, but we don't need to go into that now. So the program itself is going to be running around the loop very rapidly. And I'll just walk you through the code so you can see how that looks. So the magical program. So right at the very top of the program here, we have a load of variables. We don't need to worry about the variables themselves. The two interesting points on the screen are these arrays. So this array and this array. This array is the different timings for each of the RPMs for the Tacho. So you can see there it's 14,930 microseconds delay between each of the pulses in the square wave corresponds to 1000 RPM. You can see there 2,134 microseconds, which is about 2 milliseconds, corresponds to 7,000 RPM. Same for the Speedo here. There's a slightly longer array. Obviously it's from 10 miles an hour up to 160, and you can see there the delay between the pulses is 56,300 microseconds, 56 milliseconds, down to 3,500 microseconds. So after the couple of arrays with the timing, we have setup, which we can largely ignore. We don't need to talk about that particularly. Then we have the main loop. Now the main loop is split into 3 sections. We have one section for the Speedo, one section for the Tacho, and then this bigger section down the bottom here deals with incrementing. It's the bit that makes the revs go from 1,000, 2,000, 3,000, and the Speedo go from 10 miles an hour, 20, 30. It sort of steps through the different settings. So if we just focus on the Speedo for the moment, because the Tacho is largely the same, what we need to do is produce a square wave. Now the way we're going to do that is, as the program runs, it iterates around this very rapidly, and we time how long it takes, and we keep adding that time onto a counter, and when it goes over a certain amount, we reset the counter and change the voltage from high to a low or low to a high, and that's how we get a square wave. So the first point here says if the speedo is high, so if it's 5 volts, then if we've counted a certain amount of time, the speedo goes to low and we reset the time. And on the other side of that, if the speedo is low, if it goes over a certain threshold, set the voltage to high and reset the time. And that will produce, it's low, certain amount of time goes high, certain amount of time goes low, certain amount of time goes high, like this, backs and forwards. Now it's exactly the same for the tacho there. And the increment, this deals with, initially we're going to be running at the lowest setting on both Speedo and Tacho, so that's 10 miles an hour and 1000 RPM. After a certain amount of time, which I called speed in this case, it will increment, so it will go from 10 miles an hour to 20. And if we refer back up to the top here with the Tacho array, so we start with the 1000 RPM, after a certain amount of time we'll go up to the 2000 RPM, then the 3000, then the 4, all the way up to 7, and then back down again. And you can see when you watch them working, they step through the different settings. Now that's all there is to the program. It's pretty straightforward. It may look scary, but as I say, just cut and paste it from the description into the Arduino IDE and click the tick just to check it compiles. If it doesn't compile, check you cut and pasted it all correctly. Just sort of look it over, make sure it looks right. You can always leave me a comment in the video description, the comment section, and I'll reply and try and help work out what's wrong. But it should be straightforward. Right, so here we have the Speedo running, Tacho's running next to it. Now we're going to look at the calibration. What we can do, it's difficult now because it's stepping through all the different speeds. But I'll quickly show you where it is, and then I'll show you the actual process of calibrating this. So underneath here, I've just moved it back. There's a little tiny variable. You can put a screwdriver on it and adjust it. And if you watch, oops, if I can just get my finger on it. If you watch, it changes. So if I move it quickly, you can see it's sort of gliding up and down a bit each time it steps. That's roughly the amount of adjustment we have. It's the same on the Tacho, but we can't do it while it's moving around like this. So what we need to do is set the program to output a known speed. And what I'm going to do is set it to 100 miles per hour. So at the very top of the program is a variable called calibration mode. Set that to true, so just change that to say false, change that to say true. And then down the bottom, if we just scroll through, here, this is inside the loop, there's calibration mode, and it hard sets the speed index to 9 and the Tacho index to 3. That corresponds to 100 miles per hour and 4000 RPM. So if we now click the build button and deploy at the top here, that will build across onto the Arduino. So you can see the needle has come up, and on my one it's sitting about 92 miles per hour, something like that. So what we can do is just use the calibration screw at the bottom there and rotate it, and you can see this, the dial, or the needle, sorry, is moving, and I've set that to 100 miles per hour. Now the other thing to note is that it all depends on whereabouts you have the needle set on the spindle. So if I remove the power going to the Speedo, it comes down to 0 nicely. It's important because it could have come down to here somewhere, which means I've got the needle stuck on wrong. But mine's stuck on relatively okay, I think. So just plug it back in. Now what I'm going to do is turn it off calibration mode. So I just changed the calibration mode to say false. Then I click the build button again, and build across the Arduino. And that's now stepping through the different speeds again. So now I can see it's slightly off still, so I'm going to repeat the process, go round and round until it reliably stays at what I want. at the 100 miles per hour. And you can vary it. I mean, this is setting it to index 9. I also perform the test at down at 50 miles per hour as well, trying to get a couple of different reference points. But basically just keep repeating that until you get a fairly reliable reading. And what I find is that there's a lot more error at the top of the range than at the bottom. So I'll end up tuning this so that 100 miles per hour is about right, but I'm really focusing on sort of 50 in the 10, 20, 30, 40 area. As it goes up the top end, it goes a lot worse. So this is my Speedo now. This is at the second iteration. So all I did, I came back, put calibration mode on again, set it to just below 100, only fractionally. And you watch at the top end, it's quite a long way out. My car's never going to be going 170, so that I don't see that as a major problem. But as we come back down, so 90s close, 80s decent, 70s good, 60s good, 50 pretty decent, 40, 30, 20, 10. They're all pretty decent. I may just tweak it a little, just to be a little bit lower, but I'm quite happy with that. Certainly, I'm not going to kill myself at the moment because I need to take the dial off anyway, because I have replacement phase dials coming. But that shows you, hopefully, how to calibrate. It's an iterative thing. You just keep doing it, run it, do it, run it, and tweak it until you're happy with the numbers. So that's all there is to it. Pretty much connect it up as I've shown you. Use the program that I'll put in the description and give it a go. It should be pretty straightforward from there. If there's any questions, just leave me a comment and everything. Please click that like button. In fact, if you like this video, go back and click like on all my other videos as well. And keep subscribing, and I'll see you next time.